Lesson 1.9, Arithmetic Sequences. So when you see this word, it probably looks like to you the word arithmetic, and it is when it's by itself. When you put it in front of the word sequence, you pronounce it arithmetic sequences. If you say it wrong, it's not that big of a deal to me. I'll know what you mean, but it is good to know what it's really called. So an arithmetic sequence is a list in which each term is found by adding the same number to the previous term. For example, right here it says 1, 3, 5, 9, and every time they add 2. So they consistently add 2 every time. That's what makes it an arithmetic sequence. You're adding the same amount from one step to the next, and then you can determine what the next numbers are in the list. So just like that, example 1 says, describe the relationship between the terms in the arithmetic sequence 17, 23, 29, 35. Then write the next 3 terms in the sequence. So you ask yourself, to go from 17 to 23, what did you do? And they say, add 6. 23 to 29, add 6. 29 to 35, add 6. So this is found by, here's the description, adding 6 each time. We're adding 6. That's the description, the relationship, adding 6 to the previous term. Now, you go on from there to find the next 3 terms. So they took 35 plus 6 and found 41. 41 plus 6 to find 47. 47 plus 6 and found 53. So therefore, my next 3 terms are 41, 47, and 53. So you're going to be doing a lot of that where you find the next 3 terms. Any questions about how they found the description or the next 3 terms? Any questions about that? Did you see that pattern? Okay, so the arithmetic sequence isn't just a pattern, it's making sure that you add the same amount from one step to the next. Let's look at example 2. It says in example 2, Brian's parents have decided to start giving him a monthly allowance for 1 year. Each month they will increase his allowance by $10. Suppose this pattern continues. Wow, that's really generous, isn't it? Yeah. I think I want that allowance. Okay, suppose this pattern continues. What algebraic expression can be used to find Brian's allowance for any given number of months? How much money will Brian receive for allowance for the 10th month? So they decided to make a table on this, and they have the position, or basically that represents what? What's the position? What do you think that represents, Trent?
Like the first month,
what?
Month,
yeah.
month, and then we gotta get to blank month.
To blank month, exactly. So this position really represents the month, and they're using the operation what month it is times 10, because every month they got $10 more. So basically what happened for month 1, 1 times 10, they got $10. And then the second month, 2 times 10, they get $20. And so on, until finally they decided on the nth month, so any month, it's 10 times n, or 10n. So every time, this is a mistake right here, it should be 10 times its position number. So 10n is for any month. So when you want to know about the 10th month, they take 10 times 10, and he gets $100 in the 10th month. All right, let's look at the examples. You guys are supposed to write down the odds. So for example or exercise number 1, it says 2, 4, 6, 8, ... What is the relationship between the terms? Brandon. They're even numbers, but what do you add from 2 to get to 4? So plus 2. What about 4 to 6?
2.
Plus 2. And 6 to 8?
2.
So the description is plus 2. And what is the next 3 terms then? Freddie, after 8, it would be what? 10, and then 12, and finally 14. So you would have to answer to get the description is to add 2, and then the next 3 terms are 10, 12, and 14. Okay, number 3. This one's making it a little harder. There's decimals. 0.3, 0.6, 0.9, 1.2. So how would we describe, Trent?
They are both adding 0.3 times.
They're adding by 0.3 because 0.3 to 0.6 is plus 0.3, 0.6 to 0.9 is plus 0.3, and 0.9 to 1.2, 0.3. We're adding. So that's a description. So Trent, we need to add 1.2 plus 0.3. How much is that?
That'd be 1.5.
So 1.5. Then add 0.3 to that, Trent.
1.8.
1.8. And then add 0.3 to that.
2.1.
2.1. So we're going to tell them the next 3 terms are what? 1.5, 1.8, and 2.1. So you figure out what the pattern is, what amount we add on each time, and then go from there. Let's look at number 5. 1.5, 2.0, 2.5, 3.0. What are they adding, Kyler? How much are they adding? To get from 1.5 to 2.0, how much did they add?
5.
Just regular 5? 0.5. So they added 0.5. And then from 2.0 to 2.5, yep, they're still adding 0.5, and again 0.5. So you would say the description is adding 0.5. So we've got to do what we just did with Trent. You go from 3.0 and we add 0.5. What would that be, Kyler? 3.5. Add 0.5. I'm kind of getting into a messing area here. 3.5 plus 0.5 is 4.0. And add 0.5 one more time. 4.5. And we're going to write for them then the 3 numbers are what, Kyler? What is it? What was the first one? We start with, they ended up with 3.0. They ended up with 3.0, so the next one is, what is it? 3.5, and then 4.0, 4.5. Those were the next 3 terms, and the description is adding 0.5. Okay, questions about that? All right, number 7. It says Mama's Bakery just opened and is currently selling only 2 types of pastry. Each month, Mama's Bakery will add 2 more types of pastry to their menu. Suppose this pattern continues. What algebraic expression can be used to find the number of pastries offered after any given number of months? How many pastries will be offered in 1 year? So if we look at this, and we think again of month and number of pastries. So month and then pastries. So in month 1, how many were there? For month 1, when they just opened, how many pastries were they selling? How many? 2. So every month they add 2 more. So month 2, how many would there be?
4.
What about month 3?
6.
So how are they doing this? What about for N months? How could we figure it out? How many are they? How do the number of pastries relate to the number of months? How do they relate?
You just count by 2 until it equals to the amount of months that equal a year.
But what if it's N? How would you say to do that?
You do 2 times however many months there is in a year.
2, well, we're just going N right now. So 2 times N. Now, the last question is, how many will be in 1 year? Well, how many months are there in 1 year? How many months are in 1 year? 12. So we're going to do 2 times 12. How much is 2 times 12?
24.
So 24 pastries. 24 pastries. That's how many pastries will be offered in 1 year. That's a lot. All right, are there any questions about finding the next 3 terms, how to find the relationship, or figuring out something there from a word problem? Notice it was a word problem, so I labeled it pastries. All right?